To do this activity, we had to use measurements and proportions to determine distances and diameters, understand how two objects in space with very different sizes at different distances appear to be the same size, measure the angular size of two objects, and measure an angle. We followed the directions from the NASA Connect website lesson guide to make our eclipse simulator using a shoebox, paper, tape, scissors, and a skewer stick. We had to use our geometry skills to find the center point on each end of the box. Then we drew a horizontal line along the center of each side of the box. At the center of one end, we punched out a small hole about 2 centimeters round. We used this as our peephole to view the objects in space. We traced the lighted end of a flashlight over the center of the opposite end of the box. We also traced a quarter on black paper and cut out the smaller circle. We measured the diameter of each circle and recorded them in our journals. Then we attached the smaller black circle to the center of the skewer stick. We set up proportions for similar triangles to help us simulate an eclipse. We know that the diameter of the larger circle divided by the distance from the peephole to the larger circle is equal to the diameter of the smaller circle divided by the distance from the peephole to the smaller circle. Once we understood the relationship between these values, we had to decide which value we needed to find. Since we already know the diameter of both circles and the distance from the peephole to the larger circle, we need to calculate where to place the smaller circle from our peephole. We set up a proportion to solve for that value. Once we came up with a number, we measured the calculated distance from the peephole and slid the skewer stick in place. We added string to demonstrate how the angular size of the objects was the same. The string helped us see that the distances and diameters were actually sides of similar triangles. We used a protractor to measure the angle formed by the string. We were able to use the same proportion to predict the diameter of an object even farther from the peephole. We checked our solutions by making a circle with the predicted diameter and placing it between the strings at a specific distance. Our small circle was able to eclipse an even larger object. The proportion helped us prove that angular size is related to the actual diameter of two objects and the distance they are from a specific point. We even covered our flashlight in yellow cellophane to demonstrate the sun's corona when we had a total eclipse. Of course, we took safety precautions and used dark sunglasses to look at the flashlight. This was just a simulation. We know you should never look directly at the sun, even during an eclipse.